Hello friends, I welcome you in lecture number 1 on F distribution. In this lecture, we are going to introduce what is F distribution and how its PDF is defined. To understand F distribution, we must have the knowledge of chi-square distribution. So if you have not seen my lectures on chi-square distribution, then I suggest you to watch those lectures first and then go for this lecture. Now, what is F distribution or how F random variable is defined? So, to define F random variable, we are considering two chi-square random variables. Suppose U1 is a chi-square random variable with nu1 degrees of freedom and U2 is another chi-square random variable with say nu2 degrees of freedom. And if we consider this quotient in which numerator is u1 random variable divided by its degrees of freedom and denominator is u2 random variable divided by its degrees of freedom, then this quotient becomes a new random variable and that random variable is called f random variable. Or we can say that this f random variable follows f distribution with nu1 degrees of freedom in the numerator and nu2 degrees of freedom in the denominator. So in f distribution we will have 2 degrees of freedom, numerator degrees of freedom denoted by nu1 and denominator degrees of freedom denoted by nu2. And the graph of F distribution is similar to chi-square distribution. We are familiar with the graph of probability density function of chi-square distribution. It is skewed to the right and it is asymmetrical. So the graph of F distribution is also skewed to the right. It looks similar to the probability density curve of chi-square distribution, having a right tail on the right side. And for different values of numerator and denominator degrees of freedom, we will have different density curves for F distribution. So you all have to understand is how F distribution is defined. So F distribution is defined as ratio of two independent chi-square random variables. Here I have written the formal definition of f random variable or f distribution. Let u1 and u2 be two independent chi-square random variables with nu1 and nu2 degrees of freedom respectively. Then the ratio capital F equal to u1 divided by nu1 in the division u2 divided by nu2. This ratio is said to follow the F distribution with nu1 degrees of freedom in the numerator and nu2 degrees of freedom in the denominator. So this is the way how we can consider definition of F random variable. It is the ratio of two independent chi-square random variables u1 and u2. In the numerator we consider u1 random variable divided by its degrees of freedom. In the denominator we consider u2 chi-square random variable divided by its degrees of freedom. And because this f random variable is a ratio of two independent chi-square random variables, and we know that values of chi-square random variable are always non-negative and these degrees of freedom are also always positive integers. Therefore the f distribution also takes only non-negative values. The values of f random variable are always non-negative because it is a ratio of two non-negative random variables. Here I have written the probability density function of f random variable or f distribution just for your knowledge. You can see here I am using nu1 and nu2 degrees of freedom and I have taken gamma function of nu1 plus nu2 divided by 2. Here gamma functions of nu1 by 2 and nu2 by 2. Here nu1 by nu2 raised to nu1 by 2 x raised to nu1 by 2 minus 1, and this term is 1 plus nu1 by nu2 times x to the power nu1 plus nu2 divided by 2, and here this is for x positive, and if x is less than or equal to 0, we will consider this PDF equal to 0. So here we can see value of this function depends on nu1 and nu2 degrees of freedom. So for different values of nu1 and nu2, the graph of this PDF will be different. So you can understand this F distribution in the sense that it depends on degrees of freedom in the numerator and denominator. So here I have shown two density curves for different degrees of freedom for F distribution. This blue density curve is sketched for nu1 equal to 5 and nu2 equal to 5, and this green density curve is for nu1 equal to 5 degrees of freedom and nu2 equal to 15 degrees of freedom. So for different degrees of freedom in the numerator and denominator, we will have different probability density curves for F distribution, and again minimum value is 0 and F values are always non-negative. So we will remember that F distribution takes only non-negative values. Its graph is similar to graph of chi-square distribution. It has a right tail or positive, it has a long tail towards the right side, or it is positively skewed. Graph is asymmetrical. So this is all information which we require for hypothesis testing related to F distribution. All we have to remember is F distribution or F random variable is defined as the ratio of two independent chi-square random variables with nu1 and nu2 degrees of freedom. Therefore, F random variable always takes non-negative values, and because it is ratio of chi-square independent variables, its graph is also similar to the graph of chi-square distribution. So remember how we can sketch the probability density curve of F distribution. This we will require this shape of F distribution in the problems related to hypothesis testing, and we will also require how to find out critical values for F distribution, that we will discuss in next lecture. So this is all about this session. I hope you like it. Thanks for watching.